Hello and welcome back everyone to another simple science video, and in this video we're going to be looking at the next type of organic compounds, and these are the alcohols. Right, as you can see, a particularly very popular and prominent alcohol may pop up to mind, that is ethanol. We use this in daily life. Okay, and today we're going to be looking at the properties, the reactions, and the ways in which we can synthesize alcohols. Okay. Now, alcohols are distinguished from other molecules and are described as a particular organic compound that has an OH group attached to it. And this OH group, known as the alcohol group, is responsible for the properties and reactions of alcohols. Now, for any other organic compound, we are going to be looking at the general formula of alcohols. Now, very similar to the parent alkanes. The only difference between alcohols and alkanes in their general formula is the existence of an oxygen molecule between 1 or 2 or 3 or any other number of its CH bonds. Okay, so of course, as I said, this is an example of an alcohol molecule with one OH group, but there can be molecules with multiple OH groups. So in this case, this molecule with one OH group would be called an ethanol. If there were two OH groups, it would be called an ethanediol. So di and tri and other prefixes to all would be describing the number of alcohol or OH groups attached to the molecule. So here are other examples of alcohol molecules whereby its names depend on the number of carbons in its carbon chain. And of course, like any other organic molecule, there can be branched molecules. In this case, this is a branched alcohol whereby there is a methyl branch, whereby there is a one carbon in its branch. And when we look at the way it's named, like in the previous types of molecules, we have one carbon in the branch and a main carbon chain of 4 carbons. So the main carbon chain has the suffix name of butanol and the prefix name, which is the name of the branch. So that is the methyl branch attached to a butanol molecule. So this whole branched alcohol will be named methyl butanol. Now let's look at the properties of alcohols. Now, very similar to any other member of the homologous series that follows a particular trend, then melting point and boiling point of an alcohol increases with the chain length, and this is due to a higher level understanding of how atoms behave, known as the van der Waals forces, and this increases the melting and boiling point of an atom depending on its molecular mass. That's just extra knowledge, but in basic understanding, you should know for the IGCSE syllabus that the melting point and boiling point of an alcohol increases with chain length. And due to this OH group, which gives rise to, again, a higher knowledge understanding of something called hydrogen bonding, due to this OH group, solubility in water of alcohols is very high. Okay, so alcohols can mix very well with water compared to alkanes and alkenes. And also due to this OH group, due to this higher level understanding of hydrogen bonding, the boiling point and melting point of alcohols are higher, significantly higher than that of alkanes and alkenes. Now let's look at the reactions that alcohols can undergo. So of course, like any other organic compound, you have combustion. Okay, combustion is when a particular organic compound or compound reacts with oxygen to form carbon dioxide and water, and this can be a complete reaction or an incomplete reaction to form carbon dioxide or carbon monoxide or both. Now the next type of reaction is oxidation. Now, what differs from combustion is the final product we're not producing carbon dioxide, but we are now producing a different type of organic compound. And in this case, where ethanol reacts with oxygen through a particular means. So in this first case, it is called microbial oxidation, whereby we are using microbes to aid oxidation. We're going to be producing a compound called ethanoic acid. Now there's a secondary method, or rather this is a more prominent method in which we can produce ethanoic acid through oxidation, and this is through heating with an oxidizer or catalyst called potassium dichromate in dilute sulfuric acid. Okay, and this is another way in which we can oxidize an alcohol to form an ethanoic acid. Okay, so these are the reactions of alcohols. And of course, there's another reaction that I listed previously called esterification, and this we will look at esterification. This is the reaction between carboxylic acids like ethanoic acid and an alcohol like ethanol. Now let's look at the synthesis of alcohols, in which how we can create alcohols. Of course, in daily life you might encounter this method of synthesis known as fermenting. This is when we commonly see as sugar fermenting into alcohol, right? Okay. Now, this method of fermentation is when we ferment glucose, whereby we introduce yeast as a catalyst into glucose at an optimum temperature of 25 to 50 degrees, and glucose reacts to form ethanol and carbon dioxide and energy, whereby energy is stored as ATP. And the synthesis of alcohols can go a different way, and this is a method that we looked previously in the chapter of alkenes, and this is known as hydration. This is when we react water with ethene in the form of steam to form an alcohol. And this reaction takes place at a very high temperature at 300 degrees Celsius and at a pressure of 60 to 70 bars, and with a catalyst of phosphoric acid. Okay, so that is the end of my IGCSE video on alcohols. And I wish you all good luck and best to your revision.